Hello everybody, welcome back. We are fixing the camera and continuing what we left off in the morning. And I have forgotten what that is. Haven't eaten lunch. But luckily I have this line that will bring my memory all back. This line was written and abandoned midway through. So spit out entity. Oh yes. Yes, this is the function that will do. And now I'm remembering. This is like that movie. A lot of movies. God damn it, I can't remember the name of the movie. That's a little ironic. Well, anyway, this action right here, this is the spitting out function. This is the effect creating an output entity. So we're going to go ahead and do that. And this comment is actually for me. Look up collision orientation code in normal physics. RSUtil. Okay, well let's just do that. I have no idea what that means. This kind of feels like the game Amnesia. You've probably watched, if you're on YouTube as much as me, you've probably watched 3 or 4 StarCraft casters run through that game. Okay, so normal physics entity. Yep. .m. So when we collide, yeah. The collision code uses a lot of lower level. I have these vector libraries that I also wrote. They're just written in C. They just do the mathy stuff, like adding a vector and scaling a vector and such. Those aren't really complicated, but stuff like trying to detect if 2 squares intersect or 2 circles overlap or whatever. Yeah, but you see, none of that is important yet. None of that's relevant to the spit out. Because first we want to find the collision detection part. And where would that be? That might just be in the game engine itself, because I don't see it here. Maybe it's collision result deltas. Nope, that's just an initialization. And that's just a application. Okay, you see this. Filter cube overlaps. And it uses the out result. And just because cube overlaps doesn't mean that it this is just the bounding box. So it's an overestimate. An upper, well, I won't use upper and lower because that's not meaningful here. Then we do a more stringent test here. And out result, I'm not sure how that's used. Yes, we return out result here. This is a pointer. So I believe out result has what we're looking for. Yes. Let me pull up the filter R, the vector library stuff. So that is called overlaps. Maybe it's called filter math, I don't know. I'm not sure. I thought all that would be here, but there's absolutely nothing in here. It's called something else then. Filter math. Filter geometry. Okay. That's right. Yeah, so there's these kind of calls. Filter, overlap, result flip. The kind of stuff you don't like to see. You don't want to write a few times because you'll probably mess it up on the second or third time. So the overlap has, yeah, it keeps track of what side, which side was hit. So if we could just access that from the collision call, that would be great, but I'm not sure if that's there, that information. Oh, I think this result is actually that, if I'm not wrong. Yeah. Yeah, that's probably right. Let me check. Do we have a collide width here? Oh, the default does nothing. And this is interesting. If you see the hard test simply always returns true. I'm not sure. I guess we only want to do the soft test with the cubes because that's all you really need if your actual shape is a cube, and everything so far is. I'm thinking in snakeable entity there's going to be more clues. Yeah, this looks promising, whatever this is. Collide with. Yep. So how are we using result? Are we actually using it as the side? Yeah, we are using result to check which side got hit. Which is weird because if I'm not mistaken, I thought we just blew that away with this guy. Hard test collides with entity. Okay, we are definitely changing the value here. And hard test, and we do jump into that, and it does go to out result. The only thing I could guess is that snakeable entity must somehow either redefine the hard test, and it does. Okay. So this is interesting. If the other object is a snakeable entity, it jumps down to one of these. So for walls it'll be this guy. And because the snakeable entity can have sub-entities and such, it does some more complicated stuff. But for, yeah, like here, it's actually, it needs the double for loop. And the default one, well, it doesn't do so much. It just does overlap check. Okay. So that's fine. That means that our result is valid in effect entity, being a subclass of snakeable entity. Okay, so wait, I was writing a line somewhere. What was it called? I think it was like spit or something. Yeah, spit output entity. Okay. So in snakeable entity we can find how we handle the collision. And that's gonna be in collide with right here. Okay. So you can see it's slightly complicated. You pick things up. Well, okay. Yeah, so this case is I've disabled this functionality for an object to pick up other objects. So what happens now is, see, there's a if false here. What happens now is that this needs to be cleaned up. I'm gonna hold on to that for now. We just check if it's the top being hit, then we set our velocity to 0, and I'm not sure I understand what's going on. For some reason the second line sets the position of the other guy to our position. So if you're hitting something from the top or the bottom, yeah, that you would stop Y at some point. I guess that part makes sense. We're not doing anything really fancy. And if we're actually overlapping with the other object, we just use this a spring force, which is just a linear force determined by how much the objects are overlapping. And that's how the objects bounce off of each other and such. Is this correct? It is, I mean, this pretty much negates the spring force thing. It makes it a bit more hacky. But if I leave it like this, we won't have things running through walls. We would have that problem otherwise, unless we got all the variables worked out. Anyway, I'm not here for that stuff, to debate that stuff, but to just copy and paste this stuff for now.